Periodic properties of the elements. Electronegativity. In this tutorial, we will be talking about, electronegativity and periodic trends for electronegativity across a period and down a group. Electronegativity. Electronegativity is the ability of an atom to attract electrons to itself within a covalent bond. Non-metal elements located towards the top right of the periodic table want to gain electrons to achieve full S and P sublevels. Smaller radius non-metals have a greater attraction for electrons relative to larger radii non-metals. The coulombic force of attractions is greater in smaller radius non-metals due to the lesser distance from the nucleus to the valence electrons. Electronegativity values range on a theoretical scale from a scale developed by a guy named Linus Pauling, and these values can differ from textbook to textbook, so be careful about that, from 0 to 4. Fluorine, located towards the upper right corner of the periodic table, right here, has the highest electronegativity value of 4. Cesium and francium, located towards the lower left corner of the periodic table, right here and here, have the lowest electronegativity values of 0.8 and 0.7, respectively, again, depending on your source, and sources can have slightly different electronegativity values from text to text and website to website. The noble gases have filled S and P sublevels, and in general, have no need to attract electrons. Now, yes, there are a couple of exceptions to the rules, but we'll deal with those later. Thus, noble gases typically do not have electronegativity values. So, for example, neon does not have an electronegativity value because if we look at its valence electrons, the 2s and the 2p sublevels are completely filled, so they do not need to attract any electrons to themselves. The halogens are the most electronegative elements, as only one more electron in the p sublevel is required to achieve a stable noble gas electron configuration. So, for example, chlorine. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. And if we count up the number of electrons in this S and P sublevels, we see that it's 7. So therefore, the desire to obtain one more electron to get its full octet is very, very high. Therefore, the electronegativity value for chlorine is 3.2. Metallic elements need to lose electrons to achieve filled S and P sublevels. Thus, metals tend to have low electronegativity values. So, for example, potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. If it loses this 4s1 electron, then it will have a noble gas configuration that is equivalent to argon, and it will be much more stable. Therefore, the desire to further attract electrons to itself is very, very low. It would much rather give those electrons up. So the electronegativity value is 0.8. Periodic trends for electronegativity across a period. Nuclear charge increases progressively across a period. The number of principal energy levels remains constant across a period. Thus, increased positive nuclear charge exerts a greater coulombic attractive force on the negative electrons. In general, electronegativity increases across a period. So we can see across period 4, the electronegativity values in general, and it's not a perfect trend, but in general will increase as you go from left to right. So even looking at period 5, starting here with rubidium and ending with the element of iodine, we can see the general trend that the electronegativity values will increase. Periodic trends for electronegativity down a group. Nuclear charge increases progressively down a group. This is true. But the number of principal energy levels increases down a group, resulting in increased nuclear shielding. Thus, coulombic attractive force decreases on negative electrons, resulting in a decreased ability to attract electrons and lower electronegativity values. So looking at group 2 and group 16 here, again, we see the general trend of decreasing electronegativity values as one moves down a group. So what did you learn? We talked about the definition of electronegativity very briefly, and then we looked at the periodic trends for electronegativity across a period and down a group. Need more help? Feel free to contact me. Have a great day.